Okay, 45. Look, when you take the test, everybody look at me, everybody look up. Okay, make sure you go slow. Like, you don't want to hurry. You don't want to hurry on the AP test either. You go deliberate. If you go fast, you'll skip things and you'll step into traps. For example, this problem here, I have seen people, the reason they couldn't figure it out on the homework is because they kept looking here. And including that in their analysis, when the instructions in large bold letters say you're only looking at this interval, so you should be starting here, and you should be stopping here. You should not be looking at that. So make sure you read slow. Next thing, make sure you do. It's like I was saying to Julia. A lot of questions are going to talk about F, F prime, and F double prime. You've got to keep straight. What are they giving you, and what are they asking about? So this one, they're giving us F prime, but they're asking about F. So you're trying to figure out when F has inflection points. How many points of inflection does F have? I'm going to get my computer so I can type up my keyboard so we can type some sentences here. So you are trying to answer how many inflection points does F have? What I'd like you to do right now to practice this idea is raise your hand and tell me, get my typer going here, hold on. Pull this out of the way. Come on. Work, keyboard work. This is not, I must need new batteries or something. Hold on. Closer to the source. There we go. Okay, typing. What I want you to answer is this question. They're asking, when does F have an inflection point? So you should be thinking F of X has an inflection point at X equal, raise your hand again, tell me what's the first, if you read the graph from left to right, what's the first X coordinate where F will have an inflection point? Just kind of an approximate X coordinate. There we go. Let's wait for a couple more. What's the first X coordinate where F will have an inflection point? Oops, thank you, Seth. Let's go, Ty.
Negative 1.8.
Nicely done. So,
Hey, do you have recycling?
not today, thank you.
Not today?
So X equals negative 1.8. 2 points if you raised your hand. F has an inflection point at X equal 1.8 because F prime of X changes, decrease to increase at X equal negative 1.8, which means, let's spell which correctly, that F of X is changing concave down to concave up at that same X coordinate. That's the idea. So any questions on what we just talked about there? Pull this up so you can see it better. Any questions about that? Bothering anybody? Oh, please, go.
I'm still kind of confused what the concave means. Like concave down and concave up. Like what's different between that versus decrease and increase?
Gotcha. Two for Josh. Let's go back to this one, Josh. Look at your reference sheet. Come on. There we go. Okay, so looking at the reference sheet, part of the challenge is a lot of things are happening simultaneously. So right here, let's clear this off, move this out of the way. Actually, that's okay, leave that there. Okay, look at I don't know, it doesn't really matter, F to start. When you look at this dot on F, right here, like maybe look at these 3 dots. There's several things you can say about those 3 dots. You can say that those 3 dots all are positive because they all have positive y coordinates. You can also say that the slope at those 3 dots, is negative because those dots are decreasing. You can say that the slope in this region is also increasing because this slope is less negative than this slope is less negative than this slope. So the slopes are increasing. When the slopes, little by little, are increasing, you can also say that this curvature is concave up. Did that make sense?
Yeah.
If I go over here, look at the red one for a second. I could say these dots are all positive values, just like those. But these slopes over here, they're all positive slopes. Why? Because these dots are increasing. So they have positive slope or positive rate of change. But I said that badly, I think. Each of these slopes is positive because the dots are increasing. But this slope compared to this slope compared to this slope, those slopes are increasing again because you've got positive slope, more positive slope, more positive slope. So this section of this red graph is also concave up because the slopes one by one are increasing. I feel I've answered your question.
Yeah, I see.
You're good?
Yeah.
Anybody else? Oh, please. Yeah.
So I'm noticing that t equal 1.75, that f double prime is going, like its slope is going from negative to positive. And so I'm assuming that that means that f prime is going from concave down to concave up. But what is f doing? That's
Okay, so we gotta say it a little slower. Okay, the first thing you said was accurate. The red graph is f double prime. The slope of f double prime, but the slope of f double prime is known as f triple prime. So at an x value of, say, 1, so here's 1, it's hard to read. So it's about 1.12345, about x equal 1.5. The value of f double prime is something negative.
right.
The slope of f prime at that moment is negative something. That's what the value of f triple prime would be that slope. And you went on to f prime and I didn't quite see the connection.
So if we go to Danica's chart, if we essentially like extend it down to where concave up and concave down are in the f prime column,
Mhm.
what would be in the f column? Like, what's f
Oh,
doing?
the f column. We know of no definitive connection, and that's why there's a blank there.
Got it.
Is that your question?
Yes.
2 more. Anybody else? Okay, cool. Any other question here? Stop the video. Oh, wait a minute, we're still working on that one back there. I forgot we're not on the reference. We're still doing this one, 45. Other questions so far on 45? Cool. So raise your hand if you know the answer to 45. How many points of inflection will the graph of f have? There we go. Let's go, Seth. E. So if I count them, here's when f prime changes decrease to increase, f prime changes increase to decrease, f prime changes decrease to increase, f prime changes increase to decrease. Another way to say it is wherever f prime has a relative extrema, that's where f will have a point of inflection. that's not stated on the chart, but that is accurate. Like, I don't think I have that on the notes. So the correct answer is 5. Regina, if you knew that? 2 more, okay. Please,
But there
Julie.
wouldn't be much of a trick here because even though it says remember the interval, there's no option that's higher than that.
Accurate. So that would be a case why some people just feel a little confused because they're like, I swear the answer is 6. Why is it not showing 6? So then they come in and ask me, and I'm like, oh, you just looked at too big of an interval. 2 more, please. Cheyenne, question?
Oh, well, I was just gonna say I also got tricked for a second because I didn't realize I didn't see the 0 inflection changing from increasing.
Oh, like right here?
Yeah, so I just thought it was 4 at first.
Oh, gotcha. No worries. Yeah, it is a good example of, again, just, follow the 2 more for Cheyenne. Follow the definition strictly and just go kind of careful. Don't go fast. So, there we go. Cool. Stop this one. Do another one.